In this video, we are going to do important questions and past year questions with respect to sum of n terms. I had made another video with respect to the same thing, but over here we are going to deal with the questions which majorly concerns all around about variables. Okay, so let's start talking about them. If the mth term of an AP be 1 by n and nth term be 1 by m, then show that the sum of mn terms is half times mn plus 1. Now, this question has appeared in 2015 and 17. See, I have been telling that past year questions, they may reappear, right? So, it is possible that these questions may appear anytime in future as well. And it is very important to do them because they give you a lot of exposure and an hands-on experience on how to deal with these tricky questions. So, let's start doing this one. Now over here they have said that mth term is 1 by n. So we will start expanding. When they say mth term, that means we are writing am equals 1 by n and we will expand it. It becomes a plus m minus 1 times d. Now the second they are telling us that nth term be 1 by n. So an equals 1 by m equals a plus, it is going to be n minus 1 times d. Now we have got two equations over here. We will solve them as linear equations in two variables, where the two variables are a and d. Mn are the given values, but a and d are the unknowns. So we need to solve for them. And I am going to eliminate over here. So elimination, I am going to subtract them. So when I subtract, a and a will get cancelled. What I will have over here is 1 over n minus 1 over m equals m minus 1 times d minus n minus 1 times d. Now taking up LCM on the left gives me m minus n over mn equals md minus d minus nd plus d. I have opened up the brackets and this negative turned d positive. So now 1d is negative, 1d is positive, they got cancelled. On the right side, I am left with md minus nd. M minus n over mn on the left. So now equating this further, what we have is m minus n over mn equals m minus n, I have taken out d as a common factor. So now m minus n got cancelled and we got the value of d, which is 1 over mn. This gives us d. Now the initial equation was am, which was equals to 1 over n equals a plus m minus 1 d. Now in place of d, I am substituting 1 over mn. So we will simplify this to get the value of a. 1 over n equals a plus m over mn minus 1 over mn. M and m got cancelled over here. 1 over n equals a plus 1 over n minus 1 over mn. Now 1 over n again got cancelled. We are left with 0 equals a minus 1 over mn. That means we have got the value of a as 1 over mn. Now, in the question, they had asked the value of sum of mn terms. They had asked to prove it equals to half times m plus n. Mn plus 1. It was sum of mn terms. So let's continue with that. Now we have got a and d. We have got the value of nth term as mn. So we are going to substitute everything in the final relation of sum of terms. Let's start with that. So they have asked Smn, which comes out to be mn over 2. 2a. A was 1 over mn plus. It is supposed to be n minus 1. Now in place of n, it is going to be mn minus 1. And d was again 1 over mn. So now we just need to simplify this. What I am getting 1 over mn as a common factor from inside, which I have taken out. That leaves me with 2 plus mn minus 1. This mn got cancelled, leaving me with half. In the bracket, 2 minus 1 leaves me with mn plus 1. And this is what they had asked. At the end, since it was a proving quotient, it is compulsory to write at the end, hence proved. We have seen that how easily we have been able to do this quotient. We just expanded the general term expression of am and an, simplified them using elimination. Once we got the values of a and d, we substituted every kind of information in the relation of Sn, and hence we got the desired expression. Let's start with the next question now. If the sum of first m terms of an AP is the same as sum of its first n terms, then we are supposed to show that the sum of its m plus n terms is 0. Over here, they're talking everything with respect to sum. So let's start writing about the information given. Sum of first m terms, Sm of an AP, is the same as the sum of its n terms, that is equals to Sn, right? Now, they're talking about the same AP, that means A and D is going to be same. So let's expand both Sn and Sn on each of the sides, which gives us m over 2, 2a plus n minus 1 times d equals n over 2, 2a plus n minus 1 d. Okay, now this 2 and 2 got cancelled. We will expand things over here, and that gives us 2am plus m square d minus md. What I have done over here, I have multiplied m and d together. So this goes, and the other way, I had multiplied m over here and d over here also. That gives me m square d minus md. Now, similarly, I'm going to do on the right hand side also, which gives me 2an plus n square d minus nd. Now, what I'm going to do, I'm going to collect the terms belonging to a on one side and terms belonging to d on the other side. So now we have 2an minus 2an equals n square d minus m square d plus md minus nd. Okay, now I get 2a common over here, leaving me with m minus n equals n square minus m square d plus m minus n d. Now what we can see, this is an identity over here. It is an identity of a square minus b square. So we will expand this by applying the factors as n minus n and n plus n. So let's write it n minus n into m plus n. In addition, it doesn't matter what comes first or what comes second. D plus m minus n d. The left side remains as it is. Now what we can see over here, this is n minus n, whereas it is n minus n, n minus n. So there is just a difference of one negative, which we need to take out. So how do we take it out? I'm taking it out not over here, but on the other side. I will do this. It comes out as m minus n. It becomes m plus n d plus m minus n d. Right? Now, we can see that we have got m minus n as a common factor on the left as well as on the right, which I will strike off. Now, that leaves me with 2a. So I'll start writing down 2a equals minus m plus n d plus d. Right? Now, that is 1 minus m minus n d. This is what I'm left with. So that means A equals 1 minus n over 2 times D. So what we have got over here, we have got the value of A in terms of D. Now, the question was asking, show that the sum of its m plus n terms is 0. Now, we have to expand for S m plus n. And let's start doing that. It becomes m plus n divided by 2. In brackets, we have 2a. So now in place of 2a, in place of a, I am going to substitute this relation which we had just established. So this is 1 minus m minus n over 2 times d plus, it is supposed to be n minus 1 times d. Now in place of n, I am writing m plus n minus 1 d. Okay, this 2 and this 2 got cancelled. M plus n by 2. I will expand things in the bracket, which results in d minus md minus nd. Now expanding the second bracket also, md plus nd minus d. Now we can see this d and d got cancelled, md getting cancelled, nd getting cancelled. So we are left with m plus n over 2, and in the bracket, everything got cancelled. That means it is 0. Therefore, when we multiply anything with 0, we are left with nothing but 0. So we have just shown that sum of m plus n terms is 0. At the end, we will write hence proved. Again, what we did, we have two expressions of sum over here, which we equated. From there, we got the value of a in terms of d. I found a in terms of d. If you want, you could have done it other way around also. You could have established the value of d in terms of a, and when you expand for sum of m plus n terms, you can substitute it in place of d. Either ways, the method is going to be almost same, and once you do that, by the end, you will be getting 0. It's just that these questions demand for little patience while doing them, because everything revolves around variables. So you just need to do it carefully and you will be able to do them, because there are very less formulas in arithmetic progression. So the questions are done in a patient manner. They will be sorted out. Okay, let's start doing the next question. It says the ratio of the sums of m and n terms of an AP is m square is to n square. Show that the ratio of the mth and the nth terms is 2m minus 1 is to 2n minus 1. Now, what we are given over here, we are given the ratio of the sums. So let's start doing it. And also note that this question has appeared thrice so far. Okay, so that means it is highly important. Now, first thing we are being told the sum of m terms. So Sm equals m over 2, 2a plus m minus 1 times d. This is Sm. Now, Sn, the ratio of the sum of the n terms, which comes out to be n over 2, 2a plus n minus 1 times d. Okay, now they have given us the ratio. That means what we need to do, we need to divide these expansions. So Sn over Sn is given to us as m square over n square. So let's now bring the expansions in the ratio. So we have m by 2 times 2a plus m minus 1 times d whole over n by 2 2a plus n minus 1 times d equals m square over n square. This is what we get. Now we will start simplifying. Over 2 got cancelled. We are left with, I will expand simultaneously in numerator and denominator. So we get 2am plus m square d minus md whole over 2an plus n square d minus nd. This equals m square over n square. Now we need to cross multiply. Once we cross multiply, what we have over here is we will get a relation between a and d. So let's start doing that. it gives us 2am plus m square d minus md. It will get multiplied with n square. On the other hand, m square will get multiplied with 2an plus n square d minus nd. Okay, we will expand things. We will have 2am n square. Be careful in doing these these expansions. M square n square d minus m n square d equals 2an m square plus m square n square d minus n m square d. Now what we can see over here, m square n square d can be cancelled out from both the sides. Okay, and I'm going to shift the terms belonging to a on one side and the leftover terms for d on the other side. So we have 2am n square minus 2an m square equals m n square d minus n m square d. Okay, now what do we get? I am having 2a m n as a common factor over here. What does that leaves me? That leaves me with n minus m on the left. On the right side, we have m n d common, and again that leaves us with n minus m. So we can see that n minus m got cancelled. Also, mn got cancelled. What we are having over here is that 2a equals d. We got this relation, right? Now, what was the question about? They had asked, show that the ratio of the mth and the nth terms is this. Now, what we need to find? We need to find the ratio between the terms. So, we need to find the ratio between the mth and the nth term, which is going to be a plus n minus 1 times d over a plus n minus 1 times d. Now, we know that d equals to a, so we are going to substitute it. It becomes a plus m minus 1 times 2a whole over a plus n minus 1 times 2a. So we are going to expand things on the right hand side in the ratio, and that gives us a plus 2am minus 2a over a plus 2an minus 2a. That leaves me with 2am minus a over 2an minus a. And I can see that we have got a as a common factor on top as well as bottom. So we are going to take it out, and that leaves us with 2m minus 1 over a 2n minus 1. So a got cancelled, and hence the ratio of the mth to the nth term comes out to be 2m minus 1 over 2n minus 1. What I have written over here is in the fraction form. They had asked for the ratio at the end. So we need to conclude accordingly an is to an. Therefore, equals, use brackets over here now when you are talking about the ratio, is to 2n minus 1. So here we got the final answer. And at the end, conclude by writing hence proved. So in this video, we have learned how to do various quotients belonging to the sum of terms with respect to all the variables. And everything was generally revolving around m and n. But it doesn't matter whether it is m, n or anything. It may be otherwise p and q. These are the general quotients that appear in arithmetic progression. So you should be practicing them properly. And if you have any doubts, you can always comment, and do subscribe to the channel for more informative and learning videos. Happy learning!